Welcome to our Makerspace Fab Lab. We've got a wall of 3D printers. So these are Fdm printers. They work by taking this plastic thread, run it down through a hot nozzle, similar to a hot glue gun, but plastic and smaller, and they build up objects layer by layer. So you can see here some examples of things printed in the Makerspace. Tend to be the objects that people leave behind. So there are test objects and things. All the serious parts usually get taken by students and then used in their prototypes. See a lot of examples. We also have some large format FDM printers. So these just print larger objects, thicker layers more quickly. Then we have a resin printer. So this works on a cool process. It's an inkjet printer. So it sprays down layer by layer little droplets of material that is then cured hard using a UV light. And the benefit there is that we can print really detailed objects. So if the camera will grab focus here, just very, very detailed objects. We can also print optically clear parts. So this telescope optics lens was 3D printed, and then you can see the shroud here is FDM printed. Without the rest of the optics, it doesn't work, but you can see it does change the light. One of our staff members actually printed glasses prescription at one point. So that's this. So he could actually rescue his vision using this fake glasses. It's kind of cool. That's our additive. For digital subtractive, we've got Cnc Mills. This small mill we use primarily for circuit boards. So if we take a copper clad board, mill away the copper we don't want to leave traces. This board's a couple years old, but we can create circuit boards here. So if you're using something like an Arduino, you have a bunch of wires stuck in a breadboard, you can come over here, make a circuit board in a couple of minutes, and it's far more reliable to solder things, and you don't have to deal with the issues of a breadboard. We also 4-axis mill that can mill plastics, some wood. We use this a lot for specifically in chemical engineering. This was a student org some years ago that they were making fuel cells for a chemi car, and they were milling out of high-density polyethylene their fuel cell chambers because the 3D printed parts would melt from the heat and the chemicals they were using. We have a textiles bench, which is currently kind of a mess, but a sewing machine, overlocker. Students use this a lot for wearable electronics, or bioengineers in particular. They'll make things like wearable heart rate monitors or ECG type stuff. You can see my attempt set learning how to sew the top shelf here. We have a full electronics setup here. So good soldering iron, good hot air reflow for surface mount components, good power supply, function generator, and oscilloscope. Everything that you need to make a circuit board over there on the CNC mill, put it together, test it. When it doesn't work, take it apart, make a new circuit board. When you're done with that process, use the 3D printers behind to make an enclosure. Basically a one-stop shop for any prototyping you might want to do. We have a large format laser cutter. This can cut basically 2.5D parts out of plastics and wood. You can see a bunch of examples here. So the challenge is that it can only make 2D parts. So you have to figure out how to design things out of 2D parts and assemble them. And if you're clever, you can do pretty complicated stuff. You can see this. Our fish tank here is all laser cut, 3D printed. You can see it uses 3D printed parts, laser cut panels. It's kind of our demo for bioengineering and chemical engineering. So we actually have a fluidized, if you can see in the back, if it'll grab the focus, there's these plastic pellets that cycle around. So they're lifted by air. At this scale, these do nothing, but these are something that you would see, for instance, at a public aquarium. So this enhances transport, so we don't get diffusion limited like we would on a sponge, and also leverages some properties of bacteria really efficient filters given their size. Things you'll learn all about in chemical engineering courses. In this room, some 3D scanners. So the first scanner is a flatbed scanner. You can put something down, it'll scan it with a laser. The second scanner here is a handheld scanner. So for instance, you can scan your arm and make something like a wrist brace that fits perfectly. You can also scan people. You can see some examples of people who used to work here. A small 3D scan of my face. Down this way, we have a vinyl cutter and a large format inkjet printer. The vinyl cutter is used for making stickers, so things that you would see on laptops. We also use it a lot for just sprucing up projects. So once you make a prototype, you may want to dress it up a little bit to make it easier to sell the idea. So at the end of the senior year, when you do your expo, you're not only judged on the thing you built, but on how well you can sell the thing you built. So for instance, this large format printer was used by a chemical engineering senior design group some years ago. They were designing a reactor system to land on Mars, turn the Martian atmosphere into fuel for a return trip. And they printed the Martian sort of landscape on this printer, and then 3D printed their unit ops, small models, to show kind of what a landing site might look like. It's kind of a cool thing. We also make posters and help with things like that. Through here, we have Eric, our director. Example of things we can do with the inkjet printer to celebrate Women's Month last year. We put together this collage, and I know it's mirrored from the webcam. Sorry about that, but that celebrates women in science and engineering. And every so often we try to update those posters with new people. This is just workspace. Students can come in here, sit, work with their teams. If this weren't coronavirus times, this would be full of students right now. Right now it's a little bit empty. Back here we have more electronics setup, so power supplies, function generators, soldering irons. We have some students working that I think don't want to be on camera. They're building a inchworm robot that drags itself along the ground for their senior design in mechanical engineering. Down here we just opened this newly renovated space, so and bear with me going down the stairs. So this space just opened up. It's our new metalworking machine shop area. So right now we just have a couple of tools, but pretty soon this will be pretty well full of mills, lathes, other things for making functional metal parts as well. So sometimes plastic doesn't work out. You've got to go for metal, or you want to go for high precision work, even in polymers. Things like lathes and mills go a long way for that. We also have a full wood shop, which is not equipped yet, but will have table saws, chop saws, everything you could possibly need to do carpentry. We have a lot of students that even just framing projects or prototyping projects, just wood is quick and cheap. This room will be a welding and painting shop. So we'll have welders in here for metal work, and we'll have a paint booth. We're planning on doing some composite setups, so do carbon fiber and fiberglass work. We have some other just metalworking, miscellaneous stuff in this area for now. Through these doors, right now there's some construction, so we can't go through there, but there's a whole separate Makerspace renovation project that's going to renovate the building in that direction. So there'll be like 3 times as much space for student organization work. Those labs will look like this. So this is for our EDT team, which is our engineering design team. So they build robots and other things for specific competitions. They're one of our larger orgs. They, for instance, I have no idea what this robot's for, but this is an old frame from a robot. You can see it's all welded steel and electronics. I'm not part of this org, so I don't know the details, but here's a giant drone. Another robot arm for something. I know some years ago, a robot that could paint. They also robots for NASA competitions and this navigation. They have another space here that's kind of for all student orgs to use. So these are the student clubs. And then I can head back upstairs and I can take questions. Hour was what it costs students to use this space and what the limits are. So if you are an engineering student at UIC, this space is free to use. We don't charge, so all the student projects, all the student org projects, it's all paid for through their funding. The university funds it. We do limit personal projects. There's no sort of dollar limit to it. It's kind of case by case, depending on what we feel you're learning from the project. And what we typically don't allow are just things that are downloaded off the internet with no real value. We want to see students doing custom designs, building things that push their limits. And we kind of evaluate student by student what that means. There are students where, you know, making a small little thing, that's pushing their limits, and we allow that and we support them. There are other students that we come to know where, you know, printing complex things is nothing to them, and we want to see them do better. We push them for that. Crazy projects that I've seen. That's a long list. I've seen some pretty cool stuff. One of the largest things we ever 3D printed, some students were working for senior design for Fermilab, and it was some kind of robotic manipulator that had to go inside of a vacuum chamber. So it was this big cylindrical vacuum chamber, a couple of feet in diameter, and they had to print this really complicated robotic hand system to go inside of it. And they decided that they needed to 3D print a full-scale model of this vacuum chamber as part of a particle accelerator. And we did it. We printed this huge thing. At the end, I think they turned it into a coffee table. That was pretty cool. I've seen projects that have made real differences in people's lives. So maybe not crazy, but pretty cool. There was a group a couple years ago that built a prosthetic arm for a girl in Thailand. They designed it from scratch just for her. There was a group that worked to make a biological control cabinet type thing for a neonatal center in Thailand, and they actually flew there and installed it. So that was pretty cool. We've seen some projects that, yeah, I've seen people build CubeSats. So I'm pretty sure some parts we've helped make have actually been in space. We had a team one year that they wanted to redesign wind turbines. So they became convinced that they could improve upon a wind turbine, and they actually built an entire wind tunnel in our basement. So that space that was I just showed you renovated before it was renovated, it was a giant wind tunnel, which according to them was actually one of the largest wind tunnels in the Chicago area for a brief time. How well it worked. It was pretty cool to stick stuff in it. That was pretty neat a couple years ago. Yeah, we've seen some pretty cool stuff. I'm helping a researcher right now. He's working on a little microfluidic device, so real small fluid, and then spins it to create a vortex that they grow brain cells in. So he sticks it in these little tiny well plates and then creates a little vortex so that it cradles and holds these growing brain cells that are, you know, just extra super fragile inside this gently rotating fluid system. I think that's pretty cool. Yeah, I could obviously talk for a long time about crazy projects, but if you have something more specific you're interested in. I think another crazy project, a couple years ago, some students decided they wanted to make a 3D printer that could print food. And so they landed on printing peanut butter and jelly. Well, first they just wanted to print peanut butter. Then that was hard, so they decided to print jelly. But then they got the peanut butter working. So they made a 3D printer. They modified it where it could take a piece of bread, could print peanut butter and jelly in whatever pattern you wanted, and then flip another piece of bread on top of it. And then that wasn't enough for them. They decided that they would want to take it on a picnic. So they installed a solar panel on the top of it so they could take it outside and 3D print themselves a peanut butter and jelly sandwich in the park. That was actually one of the crazier projects I've seen. Hilarious to watch it to work, and we ate a lot of really messed up peanut butter and jelly sandwiches to help them test. But pretty funny to see for sure. All right, well, I'll thank everyone for your time. I'm here if you have any other questions.